Okay, so this one is about simplifying square roots and cube roots. And what they say is we're supposed to know how to do these in simplest form, which does not mean put it in the calculator and then report whatever decimal value is there. Okay. If it was that easy, we wouldn't spend a day doing it. Okay. And by the way, we'll have our quiz next class. That'll be Tuesday. And that'll be over the homework we just went over and the one from the time before, the properties of exponents. I guess it could be scientific notation too. So maybe there'll be like 4 properties of exponents and 1 scientific notation. Okay. So a square root, by definition, is a number that you would multiply times itself to get the number inside the square root symbol. Right? So you're thinking, what number multiplied times itself equals 9? 3. Okay, so that's what it means to say a square root. Right? Now, a cubed root is written like this, right? It's got the square root symbol, but in the little hook, what I call the hook, in this cube root symbol, there's a 3. That's how you know it's a cubed root. Okay, you know, because a square root, you don't see anything in the hook, you assume it's a 2. It's like there's an invisible 2 there. It does have that's called an index. It has an index. The index is 2, you just don't see it. Right? A cubed root is what number could you multiply times itself to get the number inside? Does anybody know what number times itself 3 times equals 8? 2, right? So our objective is to learn how to completely simplify square roots and cube roots without turning them into decimals. Okay. So first we're going to learn how to simplify square roots of numbers that are perfect squares and cube roots of numbers that are perfect cubes. Because then you definitely don't need decimals for that. You don't need to write that down. Okay. So how do you know which numbers are perfect squares? Well, if you know your multiplication tables to a certain degree, you know, you would know some of them. And you know, like 3 times 3 is 9 and 4 times 4 is 16. Okay, those are perfect squares. Probably you get up to a certain point and you don't know them anymore, which is understandable, right? Even I don't know everything, you know, to infinity. You know, I'd probably get up 12, 13, 14, 15, 16, 17, 18, 19 I'm not so sure about. 20, I know 20. You know what I mean? Everybody knows some, but you don't know them all necessarily. But let's just go through these ones right here, right? 1 squared, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 4 times 4 is 5 times 5. 6 squared is 7 squared. 49. 8 squared. Less voices now, huh? 9 squared. 10 squared. 100. 11 squared. 121. And 12 squared. 144. I mean, when you're taking like an SOL or something like that, I mean, you got a calculator right in your hand. You should be able to figure these things out. I mean, sometimes the issue is you recognizing what you're looking at. You know, that if they give you a perfect square, a lot of times that's like a clue to how to solve the problem. But if you don't recognize it as a perfect square, you don't see that. Okay. So, you know, I have like formula sheets, and on the back of my formula sheets, I actually give the list of the perfect squares and the perfect cubes. But you ought to know how you could, you know, if you just want to have a list of the perfect squares so that you've got them like right there where you could look at them, then you can make them in your calculator by doing this, right? And you should try this now. Go to y equals, right? Y equals, and on the first line, put x squared. And then once you've got the x squared there, then you're going to go second graph, which is table, right? And you can see this is a table of all the perfect squares, right? 1 squared is 1, 2 squared is 4. You can scroll down and there's more, it goes on forever. Is everybody able to make a list of perfect squares? Okay. So how do we make a list of, or how do you know which numbers are perfect cubes? Those are not part of your multiplication tables, right? That would take multiplying some together 3 times, and that's not really what we go through when we memorize multiplication tables. But you probably know a few of them, like we already knew what 8 was, right? 8 was 2 cubed. What's 1 cubed? 1, right? 1 to any power is 1, right? What about 1 to the 0? 1. Property of exponents. Come on. 3 to the third. Do you know that one? 27. 4 to the third. 5 to the third. 125. And 10 to the third. 1,000. I skipped the ones in the middle, but I'm saying those are ones maybe you know what those are pretty easily, right? But again, you can make a list of the perfect cubes if you want to have them in front of you to help you to simplify some of these things. Then go to y equals, and this time you're going to put in x to the third. Right? And then when you go to the list, there's a table, second graph, you see all the perfect cubes. Yeah. Right? You hit x, and that is raising something to a power, any power, right? So if you have x squared, there's no reason to use that. You've got a button for that. But for x to the third, you can go there, right? Okay. So x. Okay. So I've got my list of perfect squares, and I've put like scroll down a little bit, and I pasted that there too. But with that, we can take the square roots of perfect squares, and we can find squares. Like 3 squared, we kind of already know that, right? 3 squared is, because you look at the 3 in the left column, and then the 9 is in the right. Okay. The square root of 36 means, here's the 36, the square root would be 6, right? Okay, 9 squared, 9 squared is 81. The square root of 121 is 11. 13 now is on the screen. 13 squared is 169, which means the square root of 169 is 13, right? That's how it works when you're taking the square root of perfect squares. And you can use this list. The numbers obviously can get way bigger where we don't recognize any of them. So just knowing how to go from like one column to the next to get squares and square roots, that helps. And again, here's the cube roots. 2 to the third, we already knew that one. The cube root of 125, again, I could look in this column here, and I could bring it over and say that's 5. 7 to the third, I would have to go down further. That's 343. And the cubed root of 729, what is that? 9, right? Because there's 729, and you're going to go that way, 9. So you can scroll up and down that list and find all the cubes and the perfect cubes and pick cube roots of perfect cubes. Now, what I would do is I wouldn't just make a list of the perfect squares or the perfect cubes. I would make them both at the same time. So if you go in your calculator to the y equals, on the first line, put x squared, and on the second line, put x to the third, and then you've got them all, right? Here's all the perfect squares. Here's all the perfect cubes. Okay. Now, how to simplify square roots that are not perfect squares because they're not in that list. There can be a process to this. You know, if you want to like try to turn it into something just systematic that you can do every time. Like the square root of 60. I look in my list of perfect squares here, right? These are the perfect squares. And 60 is not in the list, right? So what you can do then is start dividing 60 by all the perfect squares less than it, starting with the greatest. So start with 49. What is 60 divided by 49? We're looking for a factor of 60, so it shouldn't be a decimal. Yeah, so 60 over 49 is what? 1.22. That's not a factor. How about 60 divided by 36? 1.6 repeating. How about 60 divided by 25? 2.4. How about 60 divided by 16? Say again? 3.75. How about 66? Oh, what I got there? I wrote 16 and I meant to say 60 and 60. 60 divided by 9 is 6. Uh-oh, it's a double. 60 divided by 4, 15. Okay, there you go. You just found a factor of 60, which is a perfect square. That's what you're looking for. We're trying to, if 60 is not a perfect square, we want to break it up into factors that might include a perfect square, and then we'll simplify just part of the 60, not the whole thing. So again, you start, 60 is not in the list, right? So you can't just simplify it because it's the square root of a perfect square. So we start looking for one of these numbers, which is a factor of 60, and we found it. It's 4, right? How many times 4 is 60? It's 15, right? It's 15 times 4. So on the next slide, watch. Since 60 is 4 times 15, when I take the square root of 60, I'll say that's the square root of 4 times the square root of 15. You can break it up into two different radicals, two different square roots. Okay, now the square root of 4, we know, that's 2, right? So simplify the part that you can, 2, and then the square root of 15, it's not a perfect square, and it doesn't have any factors that are perfect squares, so you're done. Right? That's what we mean. We say simplify a square root without turning it into a decimal. That's the simplified square root. Okay. If on a test you just turn it into a decimal, sorry, no points. You're just showing me you know how to click, click, click on the calculator. Okay, try to do the square root of 72. See if you can find the factor, and not just the factor, find the greatest factor of 72, which is a perfect square. I mean, first, is 72 in the list? No, right? 72 would be in between 64 and 81. So you can start dividing 72 by 64 and then 49, right? See if you can find the factor, the greatest factor of 72, which is a perfect square. Did anybody find it? No, 2 is not a perfect square. What times 2 equals 72? 36. When you divided by 36, you got 2, right? That means 72 equals 36 times 2, which means you can take the square root of 72 by doing the square root of 36 times the square root of 2. And what is the square root of 36? 6 times the square root of 2. Now, the fact is that Micah? Aiden? Okay. Don't. Okay. There's other factors of 72 that are perfect squares, 9 and 4. I mean, if I break this down, right, 72 equals 9 times 8. So the square root of 72 is the square root of 9 times the square root of 8. And that would be 3 times the square root of 8, which is true, but it's not completely simplified, because actually you can simplify the square root of 8, 4 times 2, right? So always these questions are worded completely simplify. And if it's a multiple choice test, probably both of those are going to be options, right? One is right because it's completely simplified. The other one is not because it's not completely simplified. Okay, same thing goes for perfect cubes, right? If I want to take the cubed root of 162, first I look in my list of perfect cubes, which is this column, and I don't see 162, right? So it's not a perfect cube. I can't just like go column to column. So I'm going to start dividing 162 by the numbers the perfect cubes that are less than it until I find one of them that divides evenly into 162. If there is. Sometimes it's not simplifiable. But so what's 162 divided by 125? A decimal, right? 1.296? Okay. How about 162 divided by 64? 2.53. What about 162 divided by 27? 6. There you go. So 162 is 27 times 6. And 27 is a perfect cube, so we'll be able to simplify this a little. Right? So 162 equals 27 times 6. So the cubed root of 162 is the cubed root of 27 times the cubed root of 6. But we know the cubed root of 27, that's 3. You doing it? Okay. So let's do the cube root of 80. Right? 80 is not in the list, but where would it go in this list? It would be right in between these two. So you can start dividing by 64 and work your way down the list until you find one which goes in, if you don't recognize it already. So did 80 by 64? How about 80 divided by 27? How about 80 divided by 8? Yeah. There you go, right? And we kind of knew that, but 80 equals 8 times 10, right? So if I take the cube root of 80, that's like taking the cube root of 8 times the cube root of 10. And we know the cube root of 8, that's 2. Usually when I break them up into the factors, I always going to write the perfect cube as the first factor, because then when I simplify it, the number's in front of the radical, which is usually the way you write these things, right? Yeah.
So if you do it like a different way, but you still like
If you make factor trees and want to do it that way, I mean, I'm not going to say that you're wrong, but I'm not going to teach it that way. Okay? But to me, factor trees are kind of an elementary school kind of thing. But if you're just like going to hang on to this thing, I remember how to do that, so I'm not going to really listen to anything you're saying here. When you get the problem wrong, there ain't going to be much sympathy for, oh, I better look for a lot of partial credit here. I mean, you didn't even try the thing. You were like hanging on to the end. Okay, now there was a little bit of, there's third bullet that we were actually supposed to say a little bit about, but we're really not going to do much about this. It says, how do you evaluate square roots, cube roots, and absolute value? So absolute value really has nothing to do with this, right? But it's in the SOL. And all I'm going to say is, let's just remember know how you could do this in the calculator if you needed to. Like the square root, where's the square root function on the calculator? Yeah, it's right above the x squared. So you go second x squared, there's the square root. So try the square root of 23. Right, this is just kind of monkey business, right? What is it? 7795? 795? Ooh. I'm just going to round that then to 8. And then that's why I use my equal sign is kind of little wiggly equals, because it's approximate. I rounded. Okay, the cube root function. Right, if you want to take the cube root function, you got to hit the math key. Right, the math key is right there. And you'll see in the list, number 4, that's the cubed root. So, I mean, again, you could take cubed roots and turn them into decimals by doing that, but we don't want to just turn them into decimals. Try the cubed root of 23. 2.84. Approximate, right? Wiggly line. And then where's absolute value? We've done this before, but remember where you can find absolute value in the calculator. You can also go to the math menu, go to hit math, and then arrow over to the num. And the very first option is absolute value. So try to do this absolute value. Right, bring up the absolute value and then inside put 3. So you know how to do all that in the calculator? Got to remember. There's other places to find like all these things, like everything can be found in the catalog, which is on the on button, I think. If you go to the bottom on the 0, if you go second 0, then that's a catalog of every function. So if you don't know where else to find it, just go to the catalog. And then some things, if you go to the alpha window, then it brings up absolute value. We use that. In other classes, we use that more because we also use some of those other functions. But that's it. That is the lesson. And I'm going to give you some worksheets. There's actually 2 worksheets, but they're double-sided.